Alrighty. Hey guys, welcome Formalised and Rhef. Welcome to the stage. We got some exciting topics to cover, and we're going to start with Formalised here, our very own blockchain engineer, and he's going to talk about subnets without validators, and then we'll kick off discussion led by Rhef. So I'll hand the mic to you guys, and you can take it from there.
Hi. It's like, how do we, as we go towards evolving the protocol, what does that look like? Like, what can we do with the new tools and the new design space that opens up? So I'd like to just take everyone through a short mental experiment for what the protocol could be on different things we could evolve on. So, we've evolved a lot, and the latest iteration is DTAL. So DTAL will move from root network-based emission allocation towards a market-based. And the mental model I like to have for this is that as opposed to relying on 64 validators to determine what the subnets gets, TAL holders get to express their preferences by voting with their capital. So the more people that stake to a particular subnet, it's like a market force. It expresses, the organism Bittensor's will for the thing to thrive. So that's what that does. So when we have that, we also have we've done a lot of thinking, and we think, okay, what if, because not everyone might want to go to DTAL. Not everyone might, some people might be more comfortable here. So there is a form of DTAL that exists that people have multiple mechanisms. Now, what is a mechanism? You can look at it as a mechanism as an allocation tool. Like, what rules does the government, what rules does does that sub protocol use to allocate emissions between different networks? So that's that. So imagine a world where there's multiple mechanisms. You have the current root network running, you have STAR running, and the design space is unlimited. So okay, what else can we do if we have different mechanisms? We know what DTAL is going to do. We have an idea of STAL is going to do. Well, what more can we look to get out of this process? And this is not sanctioned. It's really experimental, and there's no code been written. There's no plans been written. So yeah, let's go. Okay, so let's go back to 101 on Yuma Consensus and how it is the best decentralized subjective utility tool out there. But again, it's good at it's the lesser of all evils at measuring subjective utility. Everything out there is absolutely terrible. It flaws. But fundamentally, I think it might be overkill for things that do not require subjectivity. So I think, let's dream of a better model. Like, can we have, another mechanism? Can something else thrive where, it's better assesses an objective good? Okay, so this is where we go to. Okay, let's think of a model. We have subnets without validators. So like DTAL will sort out will replace the allocation to subnets, but not the allocation within it. So what does this look like a subnet without validators? And how would it fit into the current system? Apologies. This is a terrible diagram, but I didn't have that much time. So this is a kind of schema that we can imagine in that, okay, you have root network working somewhere, you have like the normal YC2 working, but for some subnets or for a different mechanism, all you have is no validators, just neurons producing the digital good. They submit it to an off-chain worker / an oracle, and the subnet owner provides like a kind of a second factor authentication. This could be cryptographically signing it, or be the person that physically issues challenges to the UID. But that being said, it's like, it's a more vested party that it submits it to Subtensor, and subtensor pays it out. So that's the very high level. I mean, it's mainly a thought experiment now, but it could become something, because again, a lot of the problems we face right now is because we're trying to do subjective utility. But for some goods, maybe so things like compute storage, maybe we can possibly produce things that are even far better. Okay, so possible benefits. There is nothing like weight copying here, because there's only one judge. Well, there's only one ground truth. So there's not multiple things. So we don't have validators. And more importantly, is that one problem I see with the current system is that it's hard to ask people to validate 1,000 networks and also ask them to be in charge of selling the digital, monetizing the digital good. I mean, I love what people like Corsair and Talstats are doing, but it's really, really hard for someone to be specialized in 46 different subnets and enough to buy that to collect their bandwidths and produce the good. So I think this will solve it, because again, no one will understand the protocol and no one is more vested than the subnet owner. He gets all the bandwidths, and he is responsible for monetizing it, and profits. I think it opens up the space for not a perfect, but a more egalitarian system. Thanks. Does anyone have any questions? Yes, we can do. Okay, hold on. Come to the subnet not having significant advantage. Oh yes, Namori, I agree. So Ref, yes. So you say that the off-chain worker and subnet owners are just a single SIM validator. Yes, but again, this is just high level. We can make things trusted, proof of insurance can be interesting. We can actually punish or mitigate this thing at the protocol level. You understand? But there's also problems that the subnet owner running a minor validator. I don't have an answer for that at the moment, but it's definitely something to think about. And it's first of all, it's a problem in the current system. So this doesn't. I would argue that this neither exacerbates or ameliorates it. But again, it's probably something we should think about, because again, one of the things that might help is offering on-chain identities and working to make that civil resistance. But it doesn't complement the ethos of decentralization, because a lot of things revolve around KYC and stuff like that. And I don't think it's things we want to introduce into the ecosystem. Who runs the Oracle? Good question. So again, there's designs for decentralized oracles, there's designs for trustless oracles, but we will need to think about the mechanics, because again, it's not like a DeFi, or it's not like a price oracle, but it's an oracle of the events and a register. So we'll need to think of the design. This is exactly like modules. Which commune AI has? Well, I haven't heard about commune, but I'm sure they're doing pretty good work. Cool. Well, thanks all. I'll be answering questions in the chat, and if anyone wants to build this with me, ping me. Thanks all.
Thank you, Samuel. Excellent. So, Ref, did you want to go ahead and get started on your topic?
Yeah, okay. So I'm going to talk about scaling Bittensor validation. This is the current list of subnets. Well, okay, almost current. It's a couple of weeks old. It's a list of subnet numbers and GPUs, and I indicated with numbers how many GPUs of which type which subnet needs. And there is a bunch of the subnets that need GPU. Some of them need expensive A100s, and not every validator is willing to provide an expensive server with a graphics card to run every subnet. If we would have today a new subnet that wouldn't have any weights, but it would require an 80 gig card, which costs thousands of dollars per month. It might have a problem with attracting validators, and if it doesn't have validators, it might have a problem attracting weights. And this is a problem because ambitious, innovative subnets might be a non-starter on Bittensor ecosystem. This is not what we want. Now, this is the plan. Hope we can make it so that every validator needs to run a constant number of GPUs, regardless of whether they validate 20, 40, 60, or 100 subnets. Okay, so how are we going to do it? Let's talk about how subnets look like in terms of validation. It's a perspective. It's not a full picture, but I try to make a perspective that would, for someone who's not deeply involved in this stuff, is not a subnet owner, that people can understand. On the left side, we have a subtensor. This is basically like the representative of the blockchain. On the right side, we have the miners. There's like 200 of them, but on the slide, we've just put 4, and there is a validator in the middle. Now, the validator has a couple of components. One of them is network. On many subnets, the validator either requests or the miners do provide to the validator some kind of assets. It can be text prompts, it can be 3D models, it can be images. That entirely depends on the subnet. Yeah, so whether the validator goes to the miner and says, hey, please send this to me, or whether the miner goes to the validator and say, hey, what can I do for you? Kind of doesn't matter. It's almost the same thing. Then we have a preprocessor. So this is not the case in every subnet, but for example, we do have a subnet, I think it's number 17, which gets a 3D asset from the miner, then renders it and makes kind of screenshots of it from different angles. And those screenshots then get evaluated. Not actually the 3D model gets evaluated, because that's very hard. So they make photos of it and look at the photos. We have a GPU in many subnets, as we've seen on the previous slide. And then we have a scoring algorithm, which takes whatever the GPU says, which is like whether this particular image shows at this particular asset, let's say it's a car or a ball or whatever, whether this shows the ball or not. This is then interpreted into scoring, which like indicates what relative quality this miner has. No, what absolute quality this miner has. And then we have memory, and we store this scoring in memory, which eventually gets turned to weights. So the tests are executed frequently, and they are pre-processed, evaluated GPU, scored and committed to memory. And then every now and then, let's say 10, 20, 60 minutes, they are sent to subtensor. And now let's go through this process again. Files are being sent through the network to the validator, which pre-processes it, then evaluates it on the GPU, has those scorings that commits it to the memory, and eventually, sometime later, it goes from memory to the subtensor. And then eventually the chain rewards miners proportionally to their weights. Now, the network can be a problem. There are some subnets which already struggle with enough assets. It's just like if you have a few megabytes of an asset, let's say 5 megabytes, then on a gigabit network, you can only get 200 of these per second. But if miners are rewarded by the amount of assets they can generate, they can overwhelm the validator with the assets that they're providing. And also, the GPU can get on fire. There can be maybe not volume of data, but amount of prompts or images or something can be so high that the validator cannot possibly evaluate all of them fast enough on a single GPU that it has. Now, the plan is to use compute hoard for validation. So how would that work? The miners would send the assets to compute hoard, which would, I think it's not indicated on this image, but they would get pre-processed in compute hoard, and the scoring information would be sent to the validator. So the validator in this image does not have a GPU. This actually, technically speaking, it should probably, compute hoard should download the asset from the miner. But that's a technicality, who initiates the connection. And then the validator will have an execution agent, which may be on the separate machine, maybe on the same machine, and it will use that one in just a moment for cross-validation. It's a little thing that I will explain in a moment. But in the end, the weights are sent to memory. However, from memory to subtensor. However, sometimes the same data that got evaluated on compute hoard will also be evaluated on the trusted local execution agent. That is the hardware run by the same validator. So let's say it's 3%. So for 100 requests, randomly we select 3 of them and we run them locally. Because the validation will be deterministic, we will come to that in a second, the results of the execution on the local worker and on compute hoard should be exactly the same. If they are not the same, then the validator will realize that the compute hoard miner is cheating. Because the compute hoard miner may think, okay, I'm going to register on compute hoard subnet, and I'm going to do a good job, except when a validator asks me to evaluate an asset that my miner on a different subnet produced, I'm going to say that it's awesome. It's one of the best I have ever seen. And then you could think you will make more money on the cheating or on the evaluation than actually you will lose on running an inefficient compute hoard worker. But because the subnet validator will, from time to time, but frequently enough, run the cross-validation on trusted hardware, it will realize that it's cheated, and it will send the information to compute hoard. Now, compute hoard will get that information as a hint, but it will verify the claim. If a validator will say, this is actually a proof here that someone is cheating on compute hoard, then compute hoard will run it again on trusted local hardware. And if it will realize that indeed this is a cryptographic signature proving that this miner on this input using this algorithm produced this output, and we execute it again, and we have a proof that this is a deterministic algorithm, and we got a different result, then it means that this one is cheating. So we eliminate such miner from the subnet. It will not be a very good business. You can cheat like a handful of requests before someone finds out that you're cheating, and then you're removed completely. This miner gets eliminated, and another miner on the same subnet takes its place. This can happen on multiple subnets. So we can have subnet X and subnet Y. And compute hoard currently has like 2,000 GPUs that can be used for this. So a sizable amount should be enough. But then, this is a very animated slide. Those validators don't necessarily need to have a GPU per subnet. They can use one GPU to cross-validate multiple subnets because they send only like 3% of requests, or maybe 1% of requests, or however they configure it. Actually, they can initially just, when we will be testing this, we will be running 100% on the trusted hardware to make sure for a couple of weeks that it's running right before we start scaling it down. And this allows a validator to have one GPU per type per entire Bittensor rather than one GPU per subnet, as shown on this slide. Now, why can't we use one graphic card for everything? The determinism is kind of local to a graphics card type. Graphics cards are kind of over-optimized and they lose precision. So if you ask two GPUs to perform the same mathematical operation, if it's the same GPU running on the same firmware, it's going to give you the same result. However, if you ask a different GPU, it can give you a different answer. So in order to have the determinism, we need one GPU per type. And this is a little bit like more complicated flow that shows the full picture of what we can do here. And it's in the Subnets repository. Everybody can expect it, but I will use a simplified version just for explanation of what we want to do. And this, the component in the middle is called compute hoard. And it actually, for demonstration, we will show it as one component, while inside it's 4 components. So we generate like a pair of keys that we will use for access. It's like a temporary token. And then we start the green thing on the right side. We start a job, which is, for example, llama-free executor, so that you can send queries to this llama-free instance, images, text, whatever you want, and get the answer from them, streaming it back. And then this validator can run requests on it in batches. It can run it one by one. It can just run one request and then close it, whatever. And before the transmission ends, the result of the job needs to be signed by the miner, because otherwise it won't be accepted. So the miner needs to take responsibility. It needs to say, okay, for this input using this algorithm, I have provided this output. And nobody can force the miner to do that. They can compute it by themselves. And this proof can be then, if there is a cheater, this proof can be shown to other validators and say, hey, he somehow got this answer using this algorithm and this input, while that we run it again and that was not true, he's lying. And then other validators can run it on their trusted hardware, realize whether the hint is false or the miner lied, and decide who to ban and to kind of maintain the integrity of the subnet. And that's it. So I haven't been reading the chat for a moment. Let me scroll through it. Okay, actually, maybe someone wants to come on stage and ask the question. Okay, Rapido says, what happens if compute hoard has an outage? Well, pretty much nothing. So the miners still have to provide the commodity, and we can evaluate 3% of it, or so. Okay, in the first version, we don't have like a rich support for it, but the framework is designed in such a way that if compute hoard, which provides free compute to the validators, is not available, then the SDK is hookable in such a way that you can provide a different GPU provider. So RunPod, Fast AI, AWS, whatever you want. So you can assume, okay, we are going to run it for free, and if Compute Hordes doesn't work, then we just pay for pay hourly for the hardware in some cloud provider to use that as a backup. But Compute Horde won't be offline for most of the time. Oh, Subnet 11 says that they already Dockerized their miner scoring and just need to be run on any capable enough GPU. But we have to talk later about that, because if you have it Dockerized already, then we can integrate it with the SDK and should be good. We have to decouple scoring from evaluation. So it cannot be that the Docker container will say, these should be getting a score of 5. It should be able to say, this is an image of the monkey, for example, right? And then, or it's an image of the monkey that's is like 89% quality. And then their scoring algorithm actually, which turns it into weights, could be on the validator.
I actually had a question on top of that. The what you were saying about the Dockerization. So let's say in the example, I want to run the Docker image, but I also want to find something like an API key that I obviously don't want to expose to the public. Is there like some kind of encryption scheme or something that I can set up to allow whoever is running to have access to a secret at one time, but not necessarily expose it to the entire network?
Hold on, Rhef, on that note, is it possible to run it on a secure enclave? Because it sounds like that might solve Easy's concern.
I don't think that's possible. To your question, DP, we can demand from the Subnet 12 miner that in a specific hardware class, because Subnet 12 allows the miners to provide hardwares of different classes. So we can demand from them that if they want to participate in a certain class, which we're going to call Subnet 11 validators, they have to have the miner with an API key provided already. So everybody will have their own API key that they will have to acquire prior to exposing this miner in our subnet. So they will bring whatever is necessary to help do the compute work. And if it means they will have to get an API key, then that's the job.
Okay, that makes sense. Yeah, cool.
Okay. Easy trades. How about you?
Hey, I think I heard you say that a validator can now have one GPU for all subnets instead of multiple GPUs. How it is now is any number of GPUs depending on what the subnet requires. But so if it goes to one subnet or one GPU for all subnets, is there a certain type of GPU you need?
Right. So in this particular case, some subnets need different type of hardware than others to provide the validation. So let's say that we have like two popular choices. One is 4090, which is a very cost-effective card for running smaller models. So a validator will need to have one of those. And there is another one, which is A100, it has 80 gigabytes of memory, and it can run big models, although slower. And the validator will need both of those in order to do cross-validation. Because if it asks Compute Horde to calculate something on 4090, it cannot perform the cross-validation on A100 because these are different graphics cards. They have different optimizations, different precision, and different rounding, and it will just give you a different answer. However, what we could do is try to convince everybody to start using A100. And then theoretically, if every subnet says, okay, we need A100 for validation, then a validator will only need one GPU. And it actually, this GPU doesn't even have to be full-time. It can enable it for a few minutes per hour on some platform that charges per second, and that should be enough. The first version, you have to have a GPU server running 24/7. But in the future, we can actually reduce it to a fraction of that. So run validation on all subnets with a fraction of a single GPU. That would be ideal one day. Currently, it costs tens of thousands of dollars to run a single validator on all subnets. So bigger validators somehow, like, they bite the bullet, but the smaller ones, they have to wait copy because just they don't generate enough revenue to be able to pay for all the servers. Okay, let me scroll through the chat. Rail Minach Metov. I hope I didn't butcher your name. So he says we cannot run deterministic jobs, and that it is much slower to run deterministic jobs. Not quite. We managed to run it fast enough. And make it deterministic, but per hardware type, not deterministic at all. If you want to run it fully deterministic, so that it's a portable algorithm and gives you the same answer on different GPU types, this will be super slow. Like, I don't want to say 1,000 times slower, but something like that. Tens or hundreds of times slower. But if you restrict yourself to the same GPU type and same firmware version, it's okay. There is a little bit of an issue with streaming and batching. So on some of those GPUs, you can run multiple jobs at the same time, and it will be faster than running jobs consecutively. So start one, wait until it finishes, and start the other one. And this can give you a boost of like 10 times, 30 times. So then in order to maintain the determinism, you have to keep the same batch. Running the same job in a batch, but in a different place in a batch, can give you a different answer. But if you run the same batch on the same type of hardware, on the same firmware, you're going to get the same answer. Namoray says, time to first byte is extremely important, getting delayed massively here. Necessarily. If a validator needs a trusted GPU, how does it help? Well, it needs one. Doesn't need 40 of them. There are some subnets which are already overwhelmed by a number of requests. They would need multiple GPUs. And the subnet code isn't actually prepared for this. The SDK that we're going to inject into the code of the subnet, we're going to provide a nice interface for developers, is going to have an abstraction which will allow running things on compute core, but also providing multiple. There will be a plug multiple of those. So if you do have 8 graphic cards for your validator and you want to run everything locally, you don't want to use computer code at all, it's a matter of configuration. You can do that. There are many alternatives. Yeah. So in this SDK, we can plug something else as well. It's just for those other things you have to pay. And because validators are representing tau holders, they are entitled to use the resources of the subnet. So they could pay for the hardware, but they could use the free stuff that they get for subnet 12. Some validators use GPU not to evaluate, but to generate requests. Yes, this is entirely possible. You can, like, the validator doesn't necessarily have to evaluate an asset provided by the miner. They can use these GPU instances to generate queries as well. How do you optimize as a validator if you're running on a shared hardware? Well, nobody's forcing you to. It just, you can do it. You don't have to have a dedicated GPU for every subnet. Now we will be able to share them, the ones that you have on low traffic subnets, and you will be able to offload the compute to different sources. Namore says some subnets need huge models. Yeah. So for some things, you need a model that can have like 150 gigabytes. So it is impossible for a miner on subnet 12 to download this model whenever it gets a request. That would be a huge burden. So what we would do instead is we would say, okay, for Vision subnet validation hardware class, you need to have this model locally already. And if we ask you to boot it up, you need to do it in a few seconds and set it to a streaming mode so that it then can solve queries nearly instantly. And subnets, like the hardware classes that have to have some models pre-cached, I think we actually have it already in the code. It's not all finished. This is not like you can go and download the SDK and hook it up to your subnet and it's going to work today. But this is something that we're going to have in a few weeks. It's a good moment to discuss it. If someone thinks it's not going to work, please show it why. And if they want to integrate with us, let's talk about how the interface would look like. Because we currently already massively struggle with GPU validation. And it's only going to get worse if we move from 45 to 60, 80, 100 subnets. Okay, I'm reading the chat.
Rhef, so a question I had is, and I think someone also put in the chat too, is that, Bittensor has built a competition, even with the validators, you want to get the best answer. Yeah. So if they all were running on the same hardware with the same SLAs, then how do validators outperform?
Okay, so validators competing with each other is like, it could be a thing. Does it make better digital commodities?
No, it's the desired states where, Yuma, you want to be you want the similarity of the space, the vector space between all your answers to be optimal. So ideally, you want validators doing that. I mean, it's far from perfect, but I think that's where we want to get the system to. So how does running on the same hardware get us there? Or you could disagree that that's what we want to do.
I mean, they are currently running mostly on the same hardware, right? And
yeah, if they standardized, I mean, they would increase their consensus, which is the ultimate goal of the validators, right? I think to really compete in a way that differentiates each other, I think that we would need to change Yuma Consensus, right?
Okay, I didn't get it. Why would we need to change Yuma Consensus? if all the validators are providing the same output because they use the same algorithm on the same hardware, isn't that good? They agree with each other, high V-trust.
Yeah, exactly. Yeah, that's what I'm agreeing with you, Ref. I think that if we were to encourage validators to be different from each other, then that would be something we'd want to change Yuma Consensus. But right now, validators are motivated to have high V-trust, high consensus, and by standardizing on the same hardware, you're essentially contributing to that common goal, right?
Yeah. So maybe you could use dedicated hardware. Like, I don't think it will help much. There are other techniques, most of them malicious, that validators can use to improve their odds. And I don't think this is a good game to play. So if we can flatten it out and we can say, okay, if you're doing a good work as a validator, then your rewards are stake proportional, then that would be good. Because if they're rewarded based on their performance, then there is an incentive to have better performance than someone else. And one of the ways of doing that is decreasing the performance of your competitor. And we don't want to go there.
Right, and Human Consensus doesn't even encourage that validators do that, right? Because you want to be in consensus with each other. You don't want to, you don't want to put the other guy down to elevate yourself necessarily, because you want to all be more or less on the same page, right?
I mean, on Subnet 9, you're going to earn more if you're going to discover a new model that is the winner earlier. So if you're going to have a significant amount of UIDs and all of those are going to put out garbage models, and every validator is going to evaluate those garbage models, except yours, because you know which is garbage and which isn't. And then when the new model that is not garbage is posted by someone else, those other validators will eventually get to it, but you will get to it earlier on because you will skip through all the garbage. And now Subnet 9 slots are free, right? So you don't even pay anything to do that sort of attack.
Yeah, and yes, that's what I'm saying is that, like, the validator minor game is far from perfect. But in the perfect world, validators are competing to find that best miner. You understand? So when you have stuff like commit reveal coupled with liquid alpha, especially liquid alpha, it even accelerates you finding that miner earlier. You understand? Yes. So validators are, they need to optimize on something. It's like, yes, they need to get the right answer, but there's also a bit of alpha and edge they should have, which isn't weight copying.
Right. So if we want to keep that dynamic, then potentially a validator can try to acquire more GPU resources from compute or from somewhere else to get a higher priority to evaluate models with a higher precision or something like that.
Yeah, agreed. Well, I think it's pretty interesting. I think it's bold, definitely. So, yeah, thanks a lot, Ref.
Okay, does someone want to come up on stage and still talk about it? I'm like 20 minutes behind in chat. You guys have been producing texts very quickly when I was talking. Okay. NASChain says they tried to do something like that and it didn't work. Okay. I mean, we've tested it on a couple of things, and when we tested it, it worked fine. But as NASChain says, with their own GPU type, have messed up their V-trust. Yeah, it needs to be exactly the same GPU type, otherwise the cross-validation won't work. Oh. Nakamoto says they've Dockerized Validator for every subnet. I love that. how much lag the compute horde will introduce to the validation process. Will it be faster or slower? Well, network latency is a thing, but if the miner is closer to the compute horde miner than it is to the validator, then it can be actually faster. And if they are in the other side of the world, then it can be slower. But this is these are going to be a few hundred milliseconds. I don't think for most subnets it will have like a critical difference.
Well, does anyone want to come up on stage and chat about this?
Railmina Metov says we will need to change code for every subnet to connect with hordes. It's a problem. I would say I agree. Not having validators on subnets is a bigger problem.
Okay, and also like so one of the things we're working on and is actually on testnet now, and so people started playing with it, is child keys. So child keys also looks at this from a different angle, in that, you know, people like even if it's solving the 1,000 subnets validation problem, is that one single entity just can't keep up. You understand? So like child keys could solve, like, you know, child keys is also a potential solution to this, because it just takes away the expectance or the obligation to run everyone's subnet code.
Okay, AM says, is compute horde also going to have the other resources needs covered as well? RAM, HDD, connection speed? Yes. We can provide different hardware types that can be suited to validation on different subnets. And some may require more memory, some may require a different GPU type, some might require higher network speed. Whatever you guys need, basically. The compute horde miners are running virtual data centers for the validators. So whatever those validators will need, they will start incentivizing for it, and then the miners will bring it. And those who will bring it first will make a lot of money on it, and those who will provide it later will still be incentivized to do so. It's actually better to provide all hardware types, because you make more power per UID this way. Some big values still wait copy despite it all. Well, yeah. The idea is okay. So this was said by Greg Beer from Rizzo. The idea is to reduce the cost of hardware. There is another project that is not done by Subnet 12, but it's being considered as one of the things that a new initiative called the White Hat Validator might work on in the following weeks, is to reduce the operations cost of running a validator, because currently you need like a sysadmin who will install the new versions and troubleshoot the low vtrust validator code and stuff like that. And most of this can be automated. There are not enough good tools for it. It can be done. It just nobody did it and published it yet. So, like, I think it should take an hour to start validators on all subnets, not a month. And then if something breaks, the validator should reinstall itself automatically, dump snapshots of the logs and local databases and whatnot, and send it to the subnet owner for investigation. Everything that I just said should not be done manually by sysadmins 20 times over, who are sick of it at some point and say, okay, I will just wait copy because it's easier. Okay, Rapido says that no subnets are playing with commit reveal. That's not true. In fact, I think commit reveal in subnet 12 is in second or third round in code review. So it's coming any day now. Subnet 12 also incentivized the miners to have big differences in performance to make it so that if the weight copying validators try to copy some weights from the past, they will miss. In order to know what weights they have to post, they will actually have to run the validation.
Yeah, but this is so I saw you posted in Church of Rao, and it helps with weight copying, but doesn't it degrade the digital good, the compute? Because sometimes, what if a validator, if the miner's performance is fluctuating, then what if the validator is sending a user's request and hits a period when the miner's performance is down?
Okay, let me explain. Every miner is encouraged to hold 2 or 3 UIDs. Let's say they have 100 nodes. Okay, so in the first epoch, they put 90 on the first UID, 5 on the second UID, and 5 on the third UID. And then on the second epoch, they put 5 on the first UID, and then they randomly select whether they put 90 on the second or on the third UID. And on the last one, they still put a 5. So every epoch, they make a random choice and decide where the high performance is going to be. So it's the same amount of digital goods. It's just displayed in UIDs in unpredictable terms. And then if someone doesn't actually test it, then they will probably, with high probability, say that the high capacity is at the UID, which does not have high capacity. And they will be only like one of the only users that will say that. Their vTrust will tank, and the APY probably as well. So
yeah, but
that is the
No, that's okay. No, you didn't explain this the other day. It makes a lot more sense now. But still, wouldn't it be better? You're still making a compromise between that and all the UID slots be used to trying to be as productive as possible.
Okay, so
but I guess it's
in Subnet 12, you can run 1,000 GPUs on one UID if you want. There is no UID pressure. I mean, we do have a miner that for some strange reason, which is, I don't understand it, but that's what he does. He registered, I know why he did it. So he registered a lot of UIDs and puts 5 nodes on each UID. But we do have a knob that I'm not touching it now, but I can do it at any point, which rewards miners for providing big hordes. So if you run, let's say, 5 UIDs with 5 nodes on each, you're going to get a total of 25. But if you would just put all 25 on one UID, then you would get a higher reward. We do have code for this. It's just not enabled. And as soon as we enable that, any miner who will consolidate their hordes into a small number of UIDs is going to be rewarded for it, and is going to outcompete the other miners who spread their hordes around the different subnets UIDs.
But your weight copying solution is almost at loggerheads with your UID mass aggregation thing, because they're still going to have to spread something. They're still going to have to, as opposed to putting all 500 UIDs behind one, 500 units behind one UID, they would have to spread some to the decoy units. And you also, even if it's not just one person, you are also sacrificing that spot for someone else that could come with 50, all in the name of playing a decoy. So you're potentially like reducing the max capacity of the network by a factor. I'm not saying it's wrong. It's just, I didn't understand when you posted it in Church of Ra. I understand it now, but I'm just looking at it from different sides. That way copying is,
So in that particular case, like I cannot prohibit the miners from coordinating with each other and borrowing nodes to each other even.
No. It's not. I'm not talking about borrowing nodes. I'm talking about everyone's a selfish, maximizing person. We don't cooperate. Yeah. Each person would have. So one person, I have 3 UIDs. I have 100 machines. I can't put my 100 machines behind one and optimize because I still need to spread them to the decoy to get some kind of reward. So, like on an absolute level, my good is reduced. Now, if we look at for multiple people, by taking up those UID slots, yes, I stop someone else from coming with focus on one UID and stack 500 machines. So I think overall it does like degrade the overall outputs of the network.
Okay, I don't want to get too deep into this, but we thought about it, and for the foreseeable future, it will be fine. So the number of real miners that can bring a significant number of machines is much smaller than the number of UIDs divided by 3. But if it will go higher, then there are 2 choices. Either increase the number of UIDs, which is something I would rather not do, although it would mess up the weight copying validators even more. Or the miners can start working together. And they're not going to be as decentralized and independent because they would have to pair up, but it would increase their rewards. So actually, if you have so let's say we turn on the benefit of having larger hordes. If you have 2 miners with 500 machines, if they consolidate into a miner that has 1,000 machines, then they will earn more.
I actually like that, and it reminds me of like a lot of so when I first saw Codent, I was like, oh, this guy's just copied Subnet 9. But what they do is kind of like force a different kind of cooperation forced cooperation between miners where your edge decays. So therefore, it's also very easier and a lot easier to like collaboratively share models. But if the HOD does that, then it's a kind of crazy forward-thinking thing that might push the system forward. One last thing I wanted to ask to understand your proposal better is if you have 3 UIDs, then how do the shitty ones not get deregistered?
Yes, you need to keep the minimum amount of nodes on that low performance UIDs to not get them deregistered. But we tweak it in such a way that you're not penalized for those. So if you the minimum amount, but then you change it over frequently enough, then you will get the bonus for it. We call it dancing.
Okay. Rapido is upset we're talking Horde, and to be honest, I only lasted. I tried mining Horde. I lasted 5 hours and got deregistered.
Okay, well, so Horde is not a very easy subnet to mine. You have to write Python code, which will dynamically provision servers according to what is required. And there are many optimization techniques like, okay, how do I make it so that my node starts within a smaller amount of time? Because if you have 4 minutes to start a node, then you're paying for those 4 minutes to a cloud provider. But if you can start the miner in 2 minutes, then you can reduce your costs significantly because you can start it later and so on. You can basically turn code into money if you have like an established company and you can, get invoices for those servers. You need to find reliable cloud providers. You need to test the machines before you start providing them here, because some cloud providers will kind of sell you an A6000, but it's going to have a quarter of performance. And our validators will just not go for it. It will say, well, it's too slow. There's a timeout, and sorry. And some validators send wrong scores to the hordes. But technically they could, but they would be heavily financially penalized for it, and they wouldn't achieve much anyway. Yeah, as Formalised Tensor wrote on the chat, but didn't say, there is a new version of commit reveal coming up, and it is not advised to implement the current version. Subnet 12 is very keen to use even the older version, but you should wait a few days. It's almost ready. The interface is going to be nicer for the subnet owners to operate. We Foundation says, can we apply self-verifiable inference, which is discussed in a paper, edge pipe, the DNN with proof production with Parkas lemma, and do code inference in the future? We looked into it, not to this specific paper, but generally these huge LLMs like Llama 3 would be very expensive in terms of compute or space or both to do verifiable inference on. Omron, Subnet 2, is trying to do something with it. But currently, I think it's like 20 times slower than inference without self-verifiable inference, which would reduce our capacity from 2,000 effective GPUs to 101. So, I mean, I'm not entirely against it. It doesn't seem like it would perform well enough. Nobody says the subnet code would need a lot of work to get to work with this. So, okay. The subnets that are struggling with this the most will be the new subnets. And they will be faced with a dilemma or whether they will want to use our SDK to do it, which is basically Dockerize the evaluator, okay, and call it through the SDK instead of calling it locally. It's going to be fine lines of code if you can Dockerize it already. So I don't think it's going to be super complicated. We've looked through the code of different subnets and identified the changes that would be required to do it. And most of those changes can be encapsulated into our SDK. So the changes on the validators will be minimal. It will be mostly Dockerization and a little bit of plumbing. And where it says TTFB is a problem, and we might need to incentivize subnet 12 miners. Yeah, okay. If this is going to be important, then that's what we're going to do.
Ref, are you asking for more money?
No. Who said that?
Incentivize your wellness mastery.
No, it's like we do have enough GPUs. So the number of GPUs, if we're going to have like more GPU work than we have, then more weights can be shifted to Subnet 12 to increase the GPU power. Or pick up the miner from Subnet 12 to stream requests from Subnet X miner to Subnet X validator. This is a very small question, but the answer is very, very complicated. In order to maintain the integrity of Subnet 12. So there is an algorithm which leaves you like little choice as a validator. You don't have like, you can use the resources, but you don't get to pick the miner. Because if you were able to pick the miner, you could always pick your miner and reward yourself for running your stuff, or running in quotes, because maybe you don't want to actually run the hardware on it. and it will be hard to determine whether you're lying or not. So in order to prevent the malicious validators from pretending that they're running their own miners, we do have an algorithm in development which will prohibit such behavior and penalize because you can't penalize a validator, but it will penalize a miner for working a little bit too closely with one of the validators. So the miners will be incentivized to work with different validators.
Hey guys, Ref, thank you for speaking up here on stage. I think this is a good stopping point for us. I think this was a really productive talk. Thank you, Formalised, as well for being up here on stage and delivering your presentation. This was.
I will stay for a while and on the chat because some people still ask questions which I haven't addressed. So I will answer all of them.
Okay, wonderful. Well, cool, guys. All right, well, I'm going to go ahead and end the call here. The chat is still active. So I'll see you guys on the flip side.
All right. Thanks for having us.
Bye.